Right. So thank you for joining me. I'm going to be presenting Kapitan. It's a tool for generic configuration management for various other front-ends for deploying or managing resources in the cloud. I'm going to give a short historical intro, a quick overview, a deep dive in the features, and then some future plans. The slides are more text heavy than that I'm going to be describing. They're meant to be looked at after the actual talk for references. So a very quick intro. Kapitan was developed in-house at DeepMind Health, which has now moved to Google. It was open sourced in October 2017. You can basically write your templates for your various components in 4 languages or input types at the moment. So JSONet is a very popular one, Jinja 2. Helm charts can be imported, and then their values can be overlaid with other specific values. And then Python, which gives you the full flexibility of the language to template any resource you want. Kapitan then generates YAML, JSON, or text files from these templates, which can be used in other applications. We took part in the Google Summer of Code in 2019 last year and this year as well in an effort to improve some of our features and make sure we keep building on what we have. So Kapitan is suitable for anything that consumes JSON, YAML, or TXT for its configuration. Kubernetes is obviously a big example. Terraform also accepts JSON, Spinnaker, Prometheus, Alert Manager, possibly Ansible. I haven't tried it, but it should be doable. They all consume JSON, YAML, or text. So you can probably use Kapitan to template these tools. Also, Kapitan does a lot more. It also generates playbooks, so documentation, scripts, and anything else that could be text-based. You have a feature called a hierarchical inventory, which is accessible by all of your templates. This inventory holds information specific to each target you're generating, and is used for deduplicating basically information across multiple targets. Also, Kapitan generates secrets automatically for you with various backends. Right now, these backends include GPG, GCP's key management system, and AWS key management system. Essentially, it creates a key in all of these backends and then encrypts your secrets and stores them locally in your source code encrypted. And then you decrypt them upon deployment. I'll get into more detail later. So let's have a quick overview. But before that, what are the principles? Why do we need another templating tool? The concept at the time when templating tools for Kubernetes or Terraform weren't that available was have everything for your infrastructure checked in version control. So everything including Kubernetes, Terraform, all sorts of other technologies you use to deploy something and have it run on the cloud or in a data center. You want to abstract the operations on these resources as much as possible. So you don't want your DevOps or whoever's operating these cloud infrastructures to have to remember various command line arguments or how do they log in to specific environments to do something. You want to script all of that in a nice templated way that is replicatable in different environments with different infrastructure details, like different networks, for example, different cluster setups. So all of that can be abstracted through Kapitan and then outputted to automated scripts for deployment. Kapitan is also great at embedding business concepts in your infrastructure as code. I'll get into that a bit later. And then the actual stage of deploying changes to your infrastructure is out of scope. So each of these tools has a different method to apply the changes from source code to the actual infrastructure. Kubernetes has its own kubectl or anything else you might use for deployments like cap or other things. Terraform has the Terraform binary, but because all of these deployment operations are tool specific, it's out of Kapitan's scope on how you deploy it. And that gives it a lot of flexibility, of course. And so a quick overview of how Kapitan works, sort of. So we have the inventory. The inventory is basically a lot of YAML classes. These YAML classes are inherited by targets. targets are equally YAML classes. Kapitan parses through each of these target YAMLs and essentially inherits all of these classes and their properties. Properties meaning keys and values that describe your infrastructure. For example, a number of deployments could be written in class A. Class B could extend that number of deployments to, for example, 10 replicas or something like that. Then target A inherits this from this class, and then the new value is this number 10 for the replicas. So this is what builds your source of truth, source of values for your infrastructure. Then you have basically your inputs. So these are your templates. These are written in Jinja, JSONet, or Python, or Helm. And then you essentially write whatever component you want here. So this could be deployments, anything Kubernetes related. It could be resources for Terraform, databases, and other stuff that you want to generate, like documentation or scripts. Kapitan takes both of these, compiles the inventory values into the templated files, and then generates the output for each target individually. The output per target could look something like this. So you could have your Terraform output, your manifest for Kubernetes, your documentation, and your scripts in various folders. At the same time, Kapitan also encrypts your secrets. So it takes the secret definition from classes in your inventory. It talks to whatever backend you use for that secret, so GPG, GKMS, or AWS KMS, and then it encrypts the secret and stores it into the output files wherever it's used. And so upon deployment, when you deploy and run the actual script, you do Kapitan reveal. It reveals the secret to whoever is deploying this. So it assumes you have the correct permissions to deploy and read the secret. And then it applies your change to whatever infrastructure you want. This actually helps a lot because by separating secrets per target, you can have use cases where developers have permission to deploy whatever change or secret they want in dev environments, but then prod environments are more locked, and you don't give developers permission to decrypt these secrets, even though they're in the same folder. So you can sort of join your two deployment strategies for different types of environments in one place, and then that place behaves correctly per environment and maintains this privilege separation. A bit zoom in into this. So you have your data, which comes from the inventory. These are some examples of targets. So you can have some dev targets, Minikube, prod. Your secrets as well are generated by Kapitan. You combine those in the templates, and it compiles to something like this. So this is an example of a target Minikube, where you have a bunch of manifests. This one is yellow because essentially it highlights that there is a secret value encrypted in this YAML file that has to be revealed before applying. You also you also generate your scripts for applying, for if you're setting up your cluster, setting up your context. So basically, no developer has to know how to switch contexts or clusters in Kubernetes. You just wrap all of that in some scripts and you abstract it for them, and you just tell them, run this script if you want to interact with this dev cluster. So some deep dive in what these targets and inventory actually is, or how it looks like. The inventory is meant to be the single source of truth for your deployments, for anything you generate. An inventory example could be like this, a target example. It inherits some classes, some common attributes, some specific attributes for Minikube, some releases which are related to your dev app, and then some other components, for example, that you want to deploy in this specific Minikube cluster. You might want to deploy a web server and a Postgres proxy as well. So all of these classes are basically other YAML files in the same repository, which have their own properties that define each of these elements. So dev releases, for example, could have your Docker tag for your applications and the release tag, right? So if you want to move an environment to a newer release, all you have to do is inherit a new class which points to the correct Docker tag, for example. this is a nice abstraction because it gives developers the huge flexibility of changing infrastructure arguments or environment variables without depending on the SRE or DevOps teams when they need to actually do these changes. They can go inside the repository, change their dev target to inherit whatever release they want. They can deploy it because they have the permissions to do so. And when they're sure that this is the change they want to apply, they just send a merge request to the repository with your infrastructure and keep it in code for permanent. Yeah, and one last comment is that the order of inheritance here matters. So essentially, whatever attributes you inherit from common, you can override them in the other classes that follow up, which gives you great flexibility because you can do certain configurations for dev targets, and then you can overwrite it in very specific components if you want different behaviors, for example. And so you're not tied to a specific configuration just because you inherit a class. So what are these classes actually? They're, again, YAML. Essentially, this is how it looks like. Everything is prefixed with the root key parameters, and that's how you reference everything in the templates as well. And then you use whatever keywords you want here to define your infrastructure. So you can set up, instance names, you can change images when you deploy them in certain places, you can build services with different types, and you can also inherit entire subtrees of this inventory in other places. So when you actually use this, and this is reclass, by the way, internally, it inherits all of this block, whether it's a dictionary or an array or a list. It will basically go under this tree and expand, which gives you great flexibility as a pattern to define some default values you want applied everywhere in all of your targets, all of your components. For example, replica number 1, that's your default. Then you want to override that if you create different components and you want them to have more replicas, for example. Oops. So using Kapitan to simplify env access, as I mentioned before, you can basically template your setup cluster scripts as an example, very simple one. So this is how it would look like. You have your source, your inventory essentially here. This is defining some cluster related attributes, right? Your zone, your name, what the type is, anything else that you wanna use basically in this. Then this is your template for your bash script. So you can see this is Jinja 2. You initialize with hashbang, you create your inventory. So this is inventory.parameters. This is the same parameters that is here, right? After inheriting all of your classes in your target. And so here, essentially, you write whatever you would write in normal bash. And whenever you want to use an item from the inventory, like the target name, for example, or the cluster name, you reference it like this in Jinja. Basically Jinja, like simple, but extended with this inventory concept, which gives you very strong reusability across multiple components. And this is how the output would look like. So you see the cluster name is replaced, the user is replaced, namespace as well. And essentially all of these are variables you can modify in different targets like dev, prod, staging, or anything else you want, and change them to whatever value you want. This is an example of documentation as well. Again, Jinja, but the inventory parameters are still here. And you can see that the final output replaces essentially all of these values. Your release type, everything else is now reflected in live documentation. So every time you compile a new target and you want to present some information to people that aren't necessarily technical about that target, you can just generate some readmes and then point people to those readmes and tell them, here's everything you need to know about this environment, which services it has, what clusters it has, what IPs it exposes publicly, for example. All of these things can be encapsulated with your infrastructure at the same place and auto-generated. Kapitan also generates secrets. So the benefit of this is that there's usually a heavy toll on DevOps or SRE teams that they have to manage secrets for different environments. And if the process is manual, it can really block continuous secret management or it can make key rotation, for example, much harder. So why not generate these secrets at the same place where you generate and template your other components? It simplifies things a lot. So this is how you would define, for example, in your inventory, again, what key would you use for these secrets? So you can see for GPG, you can use the key of this example developer to encrypt secrets. Otherwise, in GKMS, you can use this fake key to encrypt every secret, or in AWS, use this key. And so how do you actually create a key or a secret? Sorry. You can use the manual command in Kapitan. So Kapitan refs is basically references. It's an abstraction over secrets, but it's the same thing in this scope. You can write the secret to this path by using the GKMS backend based on this target's configuration, and then you input the secret file, your origin of the secret. But if you want to automatically generate secrets because you don't care what the values are, as long as they're secure and large enough with good enough entropy, you can just put in your inventory something like this key, which generates a GPG secret for a specific target, saves it in this path, and the secret, if it doesn't exist, that's what this OR operator does, it will be generated as a random string and base 64'd. So essentially it generates your secrets and then you can modify them in the format that you want to consume them in. So base 64 is a common example for Kubernetes secrets, which have to be base 64'd, and you can do that in the same place you generate them with one simple step. And then how do you actually create and use this secret? So you've defined your secret here, you've defined your key, and then compiled output from Kapitan will contain this. So you notice that this is basically the same, but there's a hash here. This hash is a hash of your secret contents. And the purpose is that if you update secrets, you want to have this visible in your Git or SVN or whatever version control system. So this hash, when you parse this entire file through Kapitan reveal, which is a different command, it will decrypt this magic string and replace it with the actual value of the secret, which you can do upon deployment, on that deployment step. So an expansion maybe on the business concepts. So given we have these tools, the inventory, the classes, the templates, and the secret management, how can we organize our infrastructure in a way where maximum reusability is achieved for the values as well as the template code? Because you don't want to write the same deployment code over and over or copy paste it 1,000 times. And then if you ever need to change anything, you have to change it in 1,000 files. So app releases sort of can now be classes. What this means is that every application you deploy in your infrastructure probably has some command line arguments, some images, Docker images, or maybe files mounted, volume mounts. All of this can now be expressed as a class, and then you inherit it to specific targets you want. Essentially, you can express all of these app-specific features as a class, which you inherit on your cycle of release. So dev targets would inherit it first, then UAT or whatever else you have in your environment, staging, and then production. And all you essentially change in these targets is you inherit a different class each time. And therefore you change these attributes like app flags. This helps you very easily to create multiple identical environments to test business logic. So there's a new feature, you want to test it, but you don't want to deploy it anywhere unsafe. You can deploy it in dev targets, for example, first. Kapitan will compile that and show you what the difference is when you change a new release. And then you can compare that with the changes you expect, make sure those are correct, and then deploy it in all of the other stages. Now, besides that, you can abstract more concepts into classes. So your dev targets or staging or prod, all of these environments have some common concepts. For example, user access or production environments could be more hardened in various ways, networking-wise. Maybe they don't have custom networks to allow for developers to do some things. So all of these specifics can be grouped into classes, and then you have an assurance in code that all of these environments that are dev have the same behavior and same configuration and setup. And so if you see a different problem or you have to debug something and you're not sure what's wrong, you can compare two environments and use Kapitan to basically tell the differences between those two environments and easily triage your debugging process. Also, you can put data center specific or cloud provider specific information inside these classes. So if you deploy the same microservices in AWS or GCP or a custom data center, you can change whatever specifics those places have, but the rest you can just reuse across all targets. So maybe the network is different in all of these resources, or some credentials or some users are different. You can encapsulate that in a class and then inherit it only to targets that run on AWS, for example, or GCP, or whatever else. This is an image that sort of demonstrates this concept better. So you have these underlined boxes are essentially your targets, your leaves in this Kapitan inventory. You can have multiple dev targets, for example. All of these dev targets could inherit a release 1.1, which is basically release 1.0 plus a new feature. This new feature changes some config or a flag or whatever else. This is a class, a YAML class. It also had an old feature, feature A, which is also currently deployed in production, right? So your dev targets now inherit the old functionality, exactly the same as it is in production, plus some new functionality or configs, which is what you want to extend on. At the same time, you can have generic classes that are inherited by all of your targets, like security features. Something needs to be hardened in some virtual machine or some Kubernetes configuration, and so you want to make sure you inherit that in every single target everywhere, and you're not forgetting to update one specific environment. So just inherit that class everywhere, and that's it. You're done. You probably don't even need to copy-paste this into multiple places because it's hierarchical. If you inherit this class high enough on the list, for example, in common, you can make sure that it's inherited in all of your targets. And so when I mentioned business logic here, I basically meant that when your developers want to test a new release, they can easily test it on dev, and then all they have to do, for example, for the staging environment, is change one class name to release 1.1 instead of 1.0, and that will be inherited in all of the staging environments. Then you just deploy that. People, testers, QA team, an actual test, make sure that this infrastructure works as you would expect again, and then you can actually advance it to different releases and environments. The padlocks here are meant to demonstrate a secret. So in this config or class, there is a secret, same as here. I used a different color, green and red, because essentially when you automatically create secrets by Kapitan, it creates different secrets per target. So even though my secret's name for dev environments is the same, the value of the secret in production is different, which means that if a secret leaks from a dev environment, it won't be the same as the prod one, and therefore, you're not in immediate danger, although you should rotate it. So what does this mean, essentially? It gives you much bigger flexibility when you have to deploy to a lot of different environments, but at the same time, you don't want to write the same configuration over and over just to switch a couple of the parameters inside and make sure that works in your environment. It simplifies secret management, obviously, and at the same time, you have greater reusability of templated code, but the benefit as well, which I didn't mention here, is in debugging. So if you see a problem in staging or development, for example, it's much easier to debug larger microservices when you can compare the same microservice working in a different environment, and you have a great deal of certainty that all the other surrounding components around the microservice are identical. So it helps you a lot in eliminating commonalities between environments and therefore finding something that is different and might break something. Also, because everything is now in code and is also versioned, your code is your source of truth, and you can run a lot of tests on it. You can run tests on your infrastructure to make sure, for example, that your JSON template doesn't generate VMs in the region that is not supported by AWS, for example, because you can add that in code and have a list of supported regions which you want to assert on, essentially. So it simplifies testing your infrastructure a lot. Other capabilities, which I didn't create a whole slide for, but they're built in, is you can validate your Kubernetes output against the official schemas. So that was a project from last year's Summer of Code. Essentially, it downloads the official schemas from a Kubernetes repository and then validates your compiled manifests against those schemas to make sure you're not making mistakes in your deployments or stateful sets or whatever else. You can import existing Helm charts and overlay inventory values on top of them. This was useful for simplifying the migration to Kapitan for a lot of people. Secrets can accept subvariables. So up until now, secrets were just strings, essentially. So you encrypt them, you save them encrypted in the compiled output, but that's it. Then when you reveal them, it's basically a string. Now there's new functionality with subvariables. So essentially you can encrypt an entire YAML file and all of it will be encrypted in source code. And when you reveal it, you can decrypt essentially specific values from that YAML file only without decrypting the entire YAML file. So this simplifies management of like complicated secrets or larger structures of secrets significantly. We have alpha support for Vault key value. We want to extend that to the full spectrum of Vault. That would help a lot in secret integrations. We have a feature for external dependencies. Essentially, if you have multiple repositories with your components or your templates, or you have public repositories like the one we have as a reference, you can fetch them remotely with HTTPS or Git and use them in your repository the same way that you would use Git modules, for example. And one of the nicest, very new features is the embedded secrets in the compiled output. So up until now, when you encrypt a secret, it's stored in the refs folder, so refs /. Therefore, when you reveal that secret, you need that folder. It's a dependency, which doesn't work well if your deployments are done by Jenkins or some other job runner in an automated way without humans. So this new feature allows developers to store these secrets inside the actual output. So in my manifest-secret.yaml, and it's the entire secret is contained inside the same YAML. So you can reveal it without any dependencies on different files, which helps a lot if you want to do headless deployments, basically, in any CI/CD you're using. Some future plans as a last note. We want to improve the support for Vault. We want to add capabilities for remote inventory fetching. Essentially, if you have lots of inventories or classes which describe very complex information, and you want to split that to multiple repositories, for example, or reuse someone else's inventory, we want to be able to do that. We would like to improve packaging for Kapitan, the binary, and the OSX support. It works right now, but the library that is used for Helm, I think, for the dependency is not so easy to be packaged inside, so we want to work on that. We want to switch from standard JSONet to Go JSONet, which in some preliminary tests is more than 5 times faster when compiling, so that's a great bonus. We want to create a secrets controller for Kubernetes. This controller would essentially take your manifests and then reveal the secrets for you without the need for a human to have permissions to reveal them. This would allow even developers to push to production in quotes, because that's not a great strategy, without needing extra permissions, but with the assurance that all of this will work. And ideally, new input languages. It's flexible, so it could be extended to more languages. Contributions are welcome. Questions, and then 2 notes is check kapitan.dev for documentation and examples, or hashtag Kapitan on the Slack of Kubernetes.
That's great. Thanks very much, Paul. It's really, really interesting. A couple of quick questions. So first one from our good friend Renaud Gurin. So how does Kapitan compare to Customize, and when would you use one over the other?
So I'm not super familiar with Customize. That's my bad. Sorry. I'm not sure. I am not aware of Customize having the ability of an inventory or secret management. So just the templating part exists in a lot of tools, but the combination of the inventory, which is your social truth for everything, is sort of unique from what I've seen, unless I'm making a mistake, in which case I'm sorry.
No worries. And another question, sorry, from Renaud as well, is Kapitan used to only support JSON-net for templates. Is Ginger 2 now a class citizen, or are there limitations?
No, it's fully operational. We use it every day. And I would also strongly suggest people try the Cadet, which is the Python input language. It gives you the full flexibility of Python to template anything you want, to customize your inventory values in any way you want, and then generate a unique template. And because it's Python, I believe you can also modify the extension you output. I might be wrong on that. Ask on the Slack channel for more information.
Okay, great. One more question. How does Kapitan work alongside traditional configuration management tools like Puppet or Chef, or will it replace those tools?
So the concept is not to replace, more or less. It's to deduplicate and have a common set of values, your inventory, in one place instead of 15. So Kapitan essentially would probably generate your Chef configurations or your Puppet configurations, and then you would still use those tools to apply them to whatever environment you want. It's the same way that you would do it with Kubernetes or Terraform, essentially. You want your other tools to handle the deployment part and also validate that the changes you've done, the configs you've done are correct, but you want something to abstract those configs. I'll give you a quick example. So say you're creating a lot of Terraform infrastructure. You're creating a Kubernetes cluster, you're creating a database, and a network, obviously, and some other stuff. When you create these things, essentially what you get back is in your inventory some ranges, for example. For example, you can define specific ranges for your network and therefore your Kubernetes cluster. Those ranges will exist in your inventory. When I say ranges, I mean IP ranges. Then you can reuse those ranges in your firewall configuration, the same ranges exactly, without even having to remember them or copy paste them, to set up your firewall rules based on the cluster you've actually created. After that, you can also configure these things in specific resources. So if your application needs to know about the database IP, you don't have to copy paste it from the Kubernetes manifest to the Terraform manifest. You just reuse it from the same inventory. So that gives you a lot of power and way less code.
That's great. Thanks, Paul. And obviously, any more questions, just jump onto the Kapitan Slack channel, speak to the community on there, and I'm sure they can answer. So, yeah, brilliant. Just to kind of round up then, thanks very much to Alex, to Marcia, and to Paul for their talks. Really, really, really appreciate it. Some really good talks this evening. We've got 2 events coming up in June, so June the 4th and June the 18th, I believe, or 19th. If you're interested in doing a talk, if you've got something interesting that the community might like to hear about, feel free to get in touch with us. And yeah, we'll see you next time. Thanks very much. Enjoy your evening.